Hi, how are you guys? I am Muhammad Antar. In this video, I'm gonna explain the first lesson in physics for the third year secondary of the General Secondary Certificate, hoping that helps you understand difficult and mysterious points in physics and paves the way for your excellence. Let's get started. The first chapter talks about electric current, and Ohm's law. If you want to understand all things about electric current, you have to know some basic concepts of electricity. Matter, states. The first one is solids. Solids, you know solids like that, and liquid. And gas, as you see, and plasma. Do you know the difference between these states? I think it's easy to know. Solid, liquid, gas, and plasma. You know, solids like metals, like copper, like aluminum, liquid like water, okay, gas like hydrogen, and plasma. Electricity can be transferred by solids or liquid or gas. We are going to classify solids according to their ability to conduct electricity into three types: conductors and semiconductors and insulators. Conductors conduct electricity or transfer electricity because conductors have an excess of free electrons. It has excess of free electrons. What about insulators? Insulators don't conduct electricity because of their lack of free electrons. Conductors have excess. They have lack of free electrons. In another word, conductors have many free electrons, a lot of free electrons. Insulators just have a few free electrons. Conductors like metals. Metals are conductors. Copper, like copper, Cu. Aluminum. Okay. Insulators like non-metals. Non-metals like sulfur and wood. Do you know wood? Okay, wood and rubber. What about semiconductors? Semiconductors can transfer electricity. Their ability to conduct is less than conductors and more than insulators. We can say that semiconductors, their ability to conduct electricity is between conductors and semiconductors, like silicon, you know silicon, and germanium. What about liquid? Liquid can be classified into electrolytes, and non-electrolytes. Which one can conduct electricity? Electrolytes, because they have positive ions and negative ions. So electrolytes can conduct electricity because of positive and negative ions, but non-electrolytes don't have a positive ion and negative ions, so it can't conduct electricity. But what about gas? Does gas conduct electricity? Yes. How? If the gas has positive ions and electrons, it will conduct electricity. If we have a wire of copper, it will be like that. Do you know atoms? It looks like that. Nucleus has protons and neutrons and electrons. Each atom in this copper has protons, neutrons, electrons. We will just focus on electrons because, you know, in copper or any metal, just electrons can move from a region to another region. So you know that from the electron configuration of copper, Cu29, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. The final level in copper is 4s1. This electron in copper will move easily from an atom to another atom. When I wanted to draw the copper, this atom, we will just draw it like that. Positive and electron. Just one electron. In copper, we have many atoms here in this wire. So each atom in this copper will have a positive and negative charge. Positive and negative charge. Positive and negative charge. Positive and negative charge. Electrons can move easily from region to another region easily, but the ions here will stay at their position. Okay, so if the electrons flow in one direction, actually each electron here can move easily. But if I could move these electrons in one direction, I will have an electric current. So what is electric current? It is the flow of electric charge or charges through conductors. Okay, this is the electric current. The electric current is the flow of electric charges through conductors. How can these electrons move through a conductor? We have to have a battery. What is the battery? A battery, it looks like this. It has positive pole and negative pole. And if you have a lamp like this here, and wire, this is the source of electricity. Source, we can call it battery. Be careful, battery, or a cell. Many things here. So what is the difference between battery and cell? If I have one cell, I can call it battery and source and cell. But if I have two cells like this, I can call the one cell this cell, but these are a battery. Okay, I can call them the source of electricity. Okay, so where is the electric current? The electric current actually consists of electrons. So electrons in the wire can move from the positive pole here. Electrons can move here. So the motion of the electron will make a current, okay? But inside the battery, the electrons or the negative charges will move from the positive pole to the negative pole. Outside the battery, the negative charge will move from the positive pole to the negative pole. So we will call that the actual direction. Or the real direction. What is the real direction or the actual direction? It is the motion of the negative charge from the negative pole to the positive pole outside the battery, or the motion of the negative charge from the positive pole to the negative pole inside the battery. In the past, they discovered electricity before they knew the electrons. So in the past, they assumed that in the wire, the wire and the lamp, they assumed that the wire has positive and the negative charges. So they assumed that positive charges can move from the positive pole to the negative pole. So the electric current will move from the positive pole to the negative pole outside the battery. What about inside the battery? Inside the battery, the positive charges will move from the negative pole to the positive pole. Okay? So we will call that the conventional direction. So which direction we will study in this course? Actually, we will study the conventional direction. The direction of the electric current doesn't matter because the current isn't a vector quantity. Current is a scalar quantity. So we will choose one direction and we will study it. We will study the conventional direction because the conventional directions comes before the actual direction, because in the past scientists didn't discover electrons before electricity, and we have many rules in electricity depends on this direction. So if I wanted to change this direction to this direction, I will change the rules. So it's so difficult to do that. Let's talk about charge. What does it mean? You have studied in first year secondary quantity. Do you remember quantity? Units. Quantity, it is the value of something. Anything in your life that can be measured, like this pen, we will call it quantity. Okay, what is the color of this pen? It is blue and white. Could you please measure the color? No, so color isn't a quantity. Okay, what is the mass of this? How much mass in this body or in this pen? I think pen has 150 grams. So the mass is a quantity because the mass can be measured. What is the length? You can measure that with a ruler. So the ruler here, I think it will be 15 centimeters. The length is a quantity. Anything that can be measured in your life is a quantity. Like length, like mass, time. Length is a quantity, mass is a quantity, time is a quantity. If I wanted to measure the length, I should have a number. Do you know numbers? Yes. Numbers like 15, 18, like this. If I said the length of this pen is 15. 15 what? 15 millimeters, 15 centimeters, 15 inches. So I have to have a unit, okay, 15 centimeters. So there is a unit. Any number in physics, any number without the unit is meaningless, okay? So I have to have the unit. So what is the unit of the length? It is meter. What is the unit of the mass? It is kilogram. What is the unit of time? It is second. The short for length, it is L. The short for mass, it is M. The short for time, it is T. The short for meter is M, meter. The short for kilogram is kg. The short for second is S. If I write like that, L equals 5 meters. L is the quantity, equals 5 is the number, the value of the quantity. M is the unit. If I write M equals 3 kilograms, M is the mass, okay, here M is the meter, M here is short for mass, equals 3, it's the number, the quantity, kilogram is the unit, okay? We have charge. Do you know the charge? A charge is a property, okay? We write it Q, okay? A charge, the unit of the charge is coulomb. The short for coulomb is C. Many of you thinks that a charge is an object. No, the charge is a property of the body. So we can call it a charge, the quantity of electric charge or electric charge. Let's talk more about electric charge. Electric charge, we will write it in a short way, Q. Q means here in this course, actually, we can write it capital Q or small q. They are the same. Q means quantity of electric charge or just electric charge or just a charge. They have the same meaning. What about the unit of quantity of the electric charge? It is coulomb. C is a short for coulomb. Okay. So what is coulomb? Actually, if I have 6.25 times 10 power 18 electrons or protons, okay? So we will remove this. E positive, it will be protons. E negative, it will be electrons. If I have 6.25 times 10 to the power 18 electrons, it will equal 1 coulomb. One coulomb equals 6.25 times 10 power 18 electrons. So if I wanted to know the electric charge of one electron, okay, so I will divide this by 6.25 times 10 power 18, and this 6.25 times 10 power 18. These will cancel each other, so one electron equals, if I use the calculator, it will equal 1.6 times 10 to the power negative 19 coulomb. 1 electrons equal 1.6 times 10 to the power negative 19. The quantity of electric charge equals the number of these electrons times E. Actually, here we don't write X. We will put it in the magic triangle. Here. It's easy to study. Quantity of electric charge equals number times E. You can write it capital N or small n. It doesn't matter, actually. If I have a wire like that, and we will connect it with a battery, you know, this is the symbol of the battery. The battery has two lines, short one and long one. The short one means negative, the long one means positive. You now know that electrons can move from one region to another region. So, if I wanted to measure the current, how could I how could I measure the current? So I have to count the electrons that can move through the wire. You have to count the charges that can move through a cross section of the wire divided by time. Here we have another relation. What is this relation? This relation means that I, current intensity, equals Q over T. What is I? I actually means current intensity. So I is a short for intensity. Okay, I. What is Q? You know now Q, it is the quantity of electric charge. What is T? It is the time. What is the current intensity? It is the quantity of electric charge that passes through a cross section of a conductor in 1 second. Actually, don't try to memorize the definitions. This is a quantity. So what is the unit of this quantity? The unit of this quantity is amp or ampere. Ampere equals this unit, coulomb, divided by second. So if 1 coulomb passes through a cross section of a wire in just 1 second, I will have ampere. It is a current intensity or the electric current intensity due to the flow of a quantity of electric charge of 1 coulomb through a cross section of a conductor in a time just 1 second. Okay, ampere. It is the current intensity due to the flow of a quantity of 1 coulomb in just 1 second. It's easy now. So we can put them in this magic triangle. I means electric current equals Q divided by T. We can write it in a short way. Capital A equals 1 coulomb in 1 second. How can we measure the electric current? Which device can measure the electric current? Actually, we have a device called a meter. So a meter is a device. We will draw it in the circuit. This is a circuit like that, just a circle and A. You know, a meter connects with the circuit in series. Okay, so we have to connect the meter in series. You know series. If this have positive and negative, we will connect the positive with the positive pole and the negative with the negative pole in series. We will discuss that in the next videos. Okay, we should know that current has two types: direct current and alternating current. We will discuss this. If I have a relation between I and T in direct current, it will means line parallel to time. If in the alternating current means that current will change like this. Okay, we will talk in this chapter about the direct current. So what is the relation between Q, quantity of electric charge, and T, time? Actually, it will be like that. T in x-axis and Q in y-axis. So it will be like this. straight line. So if I wanted to find the slope, I should have 2 points here and draw a right triangle, and this will be delta q and this delta t. So the slope will equal delta q over delta t. It will be the electric current. Actually, I can't make it practically. I cannot do this graph in the laboratory. It's so difficult to do that. But if I wanted to know the relation between Q and T, it is proportional. It means that quantity or a charge is proportional to time. But there is no relation in direct current between current and time. You have to know that well. We have here an example. So calculate the electric current intensity that passes in a conductor due to the flow of a quantity of a charge of 15 coulomb through a cross section of the conductor in a time interval of 3 seconds. How could we solve this problem? Actually, we don't need any steps here, but if you wanted to calculate this, you have to make it simple. Here, calculate the electric current intensity. It means I equals question mark. Okay. That passes in a conductor due to the flow of a quantity of a charge of 15. It means Q equals 15 coulomb. Through a cross section of the conductor in 3 seconds. It means T equals 3. Okay? Coulomb second. So if I wanted to know the current intensity, I equals Q over T. So I should divide 15 coulomb by 3 seconds. So 15 divided by 3, it will be 5 amperes. We can write amperes, A, just like this. We can write amp, or we can write coulomb per second. Here is another example. What is the number of electrons? Oh, number of electrons. So it is N. N equals question mark. Okay. Passes a certain cross section of a conductor with within a period of 1 second. Okay, time equals 1 second. If the intensity of the electric current, it means I equals 20 ampere, 20. And the electron charge E equals 1.6 times 10 to the power negative 19. I need the number here. So how could I solve this problem? Okay, the solution will begin with this actually. N equals Q over E. But I don't have Q, so first I should calculate Q. Q equals I times T. I equals 20 times, I can't put cross here, times T 1, so it will be 20 amps. Ampere times S, or just we write coulomb C. Okay, doesn't matter. Here it's easy to calculate N equals Q over E. Q equals 20. E equals 1.6 times 10 to the power negative 19. It will be 1.25 times 10 to the power 20 electrons. It's so easy to solve these problems. Okay, here we have some notes actually. If I have a conductor here, please watch it carefully and listen to me. we have particles that have positive and negative charge. Okay, first, if each particle here has one column, okay, one column, and I connected this conductor with a battery that have positive pole and negative pole. You know, the negative charge can move to the right and positive can move to the left. If one column moves in 1 second, so the electric current will equal if two particles, two column. You know, I said that each particle of these particles has one column. Okay, and it will move in 1 second. So it will be that the current will be 2 amp. If there are three particles moved in just 1 second, I'll have 3 amps. Okay, but if one positive charge moves, it will move in the opposite direction. It will move to the negative pole. So in this state, that current will be 4 amp. If another positive charge moves, I'll have 5 amps. If all of them move, I'll have 6 amp. What about this state? Let's focus here. Watch carefully. If this particle moves in this direction, the current will be 3 amps. But if one positive moves in this direction, I will have just 2 amp. Because this positive charge will cancel this, because they move in the same direction. What about this? I will have just 1 amp. What about this? I'll just 0 amp. There is no amperes in this condition. There is no electric current here. Okay? So if I want to compare the current here, watch carefully here. I want to arrange the current in each of these conductors. So I will assume that each particle has one column. So the current here equals 1, 2, 3, but the positive charge moves in the same direction, so 2 particles will cancel 2 particles here from the negative charge. So that the current will be 1 amp. What about here? Just positive charge, so the current will equal 2 amp. Here current will equal 3 amp. Here current, so I will add the positive charge to the negative charge because they move in the opposite direction. So 1, 2, 3, 4 amp. Okay, now it's time to test yourself. Choose the correct answer. Here we have a wire and the area here is different. There are a difference between the area here and the area here. The opposite figure represents a part of a conductor that has a non-uniform cross-section through which a direct electric current is passing. So the quantity of electric charge that passes through cross-section B in a specific time interval is... Actually, there is no... A conductor can save the charge. So the charge that moves here will move here. Okay, so the current here equals to the current here. So the right answer will be equal to the quantity of charge that passes through cross section A in the same time interval. Okay, let's read this question. We have a graph here. There is a quantity of charge. It measured in column, and this is the time, the x-axis time. It is in second. So we have a straight line. So if I wanted to solve this problem here, it is a DC electric circuit. Okay, here he wants you to calculate the electric current intensity. Okay, you have to put here a point here and a point here, and make a right triangle. Okay, if you want to calculate this, you have to divide the rise over the run. Do you know the rise and the run? Okay, it doesn't matter. 24, we will subtract 12 from 24. It will be 12. Okay, column here. 4.8, we will subtract 2.4 from 4.8. It will be 2.4, and we have to divide 12 by 2.4. It will be 5 amp. Okay guys, thank you for watching. Don't forget to subscribe and like my video, and see you soon. Goodbye.